For the projectile lab, you will need a large table clamp, a projectile launcher, a plunger, a yellow projectile, a tape measure, and safety goggles. Place your projectile launcher at the edge of the table and clamp it tightly to the table.
Once you have the table clamp that securely fastened the launcher, you want to pick an angle. And so this has a protractor that's attached to the launcher with a string and a little mass hanging down. We call this a bob. So it hangs down so you can easily measure the correct angle that you want. So here you can see I have it at 30 degrees. But we're going to adjust the launcher. So come over here. So there's two screws that support the launcher, and you can see how you can change the angle very easily. So all you got to do is tighten that down lightly. No need to try to tighten it down as much as you can, because you can strip these screws here. First of all, make sure you have your safety goggles on. Now I'm going to place the projectile inside the launcher. So we're going to put it inside the barrel, and we're going to take the plunger and we're going to push it in to compress the spring. One click is a small compression, 2 clicks is a larger compression, and maximum compression is 3 clicks, which means, of course, that it's going to have more force generated on the ball. Make sure you have your safety goggles on. When you're ready to launch the projectile, all you do is pull the string. You want to make sure that you're pulling perpendicular to the barrel. So don't pull like this, and don't pull down like this. You want to pull it perpendicular to the barrel. Measure the range of your projectile. Hold the tape measure, the end of the tape measure, up against the base, which should be in line with the barrel of the launcher. And then you're just going to carry the tape measure out and measure the range. Make sure that the tape measure is flat. Here's something we need to be concerned about when performing this lab. Here you'll notice that the projectile comes out of the barrel at a certain vertical distance from the table. That means that it's launched above the tabletop, right? But when you launch the projectile, it probably travels across the table and lands on the table somewhere, which would be lower than where it started. So it has a vertical displacement. We do not want the projectile to have a vertical displacement, meaning we want the projectile to land at the same vertical height in which it was launched. So if it's launched at 25 centimeters, we want it to land at 25 centimeters above the table. So here's how I've done that. You see we have 2 stacks of boxes over there. You could do a stack of books or notebooks from your group. And I've measured so that those 2 boxes have the same vertical height as the launcher. So you can see these 2 boxes have approximately, within a half a centimeter or so, have the same height as the launcher. So now you can see I have my tape measure laid out. I have my 2 boxes placed approximately where I know it's going to land because I did a couple of trials, a couple of test runs. And I've measured the height of the launcher. I've measured the height of the boxes. They match. So now we're going to go ahead and launch this, and it should land at the top of the boxes. And there it is. So now we can measure from the base of the launcher, which is at the barrel opening, and we can measure that all the way to where the ball landed. And this lab is going to be in 2 parts. So in the first part, you want to set your angle at less than 45 degrees. And you see that you have 3 different ranges, 3 different initial positions in which the spring has been compressed inside of the launcher. So when you take the plunger and push it in, it compresses the spring into 3 different positions. So you want to take several trials at each of these positions while keeping the angle the same. So in the second part of this experiment, What you're going to do is you're going to keep the position of the spring compression the same, and we're going to choose the medium range, okay? So you won't change the spring position, and what you're going to do is you're going to change the angle position, and you're going to pick several angles from the data table as given.